Greetings and welcome to Lecture 1.1, Notation and Symbols. Now, many of you, this might be a review, but it doesn't hurt to go ahead and watch through a lecture that gives you great foundation. So let's run through a few of these. We have some comparison symbols. We have equality and inequality. And inequality doesn't necessarily mean it only involves inequality. Some inequalities actually have equality built in. Here's what I mean. Equality can be either equal to or not equal to. So if it's equal to, it's just the equal sign. If it's not equal to, then it's the equal sign with the slash through it. So it would be something how I would read A equals B, and the second one, A does not equal B. For equality, we have A is less than B, A is greater than B. And you might be asking yourself, how do you remember which is which? So if you can remember which side the arrow is pointing, the smaller sign is always going to be pointing to the smaller number. So if A is the smaller number, then A is less than B. If A is the larger number, then what happens is that the bigger side of the symbol is next to the A, so A is greater than B. Now when I said inequality can also have equality to it, that's when we use the symbol of A is less than or equal to B, and A is greater than or equal to B. For our operation symbols, let's work with addition. Addition will be A, and then we have the cross symbol A plus B. In English, we would say the sum of A and B. Our keyword is sum. Sum means addition. Subtraction is A minus B, we'll say, or the difference, if it's written, the difference of A and B. For multiplication, we have a lot of ways to symbolize multiplication. We have the dot, we have parentheses on one number versus another number or letter. We have them, if they're just letters or a number with a letter, then we can squish it together with no symbol in between. It's implied that there's multiplication. When we write it down in English, it's going to be the product of A and B. So the sum is addition, the difference is subtraction, product is multiplication, and finally we have division. And again, like multiplication, there's multiple ways of signifying that we want to use the division operation. So we have our old style, the dots. We have slash, we have like a fraction, and then we have this kind of bracket type of notation. In English, we call division quotient. So again, let me run through these. Sum is addition, difference is subtraction, product is multiplication, and quotient is division. We also have symbols for grouping. We generally use parentheses and we use brackets, which are just squared off parentheses. But please note that we will not use braces unless it's used for set notation. It's very explicit when we use braces. The nice thing about having parentheses and brackets at our fingertips is that if we have a long line of math and we want to have a grouping and then a grouping and then a grouping, sometimes it's nice to have the grouping, one of them be parentheses and the other be bracket. Not all parentheses, so we don't get confused on what's grouped with what. So let's run through some examples of using English with math. So we would say 4 plus 1 equals 5, or in English, if we wanted it a mathematical term, we could say the sum of 4 and 1 is 5. Is symbolizes equality. Also, the result can be equal, can also equal. 8 minus 1 is less than 10. The difference of 8 and 1 is less than 10. So let's decipher twice the sum of 3 and 4 is 14. In symbols, it would look like 2 times the grouping of 3 plus 4 equals 14. The product of 3 and y is greater than or equal to 15. So how do you decipher it? Well, the product of 3 and x goes all together. That would equal our 3x, be equivalent to 3x. Is greater than or equal to is going to be the symbol, and then 215 is just the number 15. The quotient of y and 2 is equal to the difference of y and 2. The quotient of y and 2 is right there, y over 2, is equal to, that's our equal symbol, the difference of y and 2 is on the other side, so y minus 2. I know this gets pretty complicated, like how do I break things up, but if you just kind of go with the sum of 3 and 4, that's going to be 3 plus 4. What's happening to the sum of 3 and 4? Well, it's being twiced. And another way of going twiced is multiplying by 2. But it's the whole entire sum of 3 and 4. So just break it down into what is touching the sum. Sum is the 3 and 4. What's touching product? The product of 3 and x. The quotient of y and 2. So you can break it apart in little groups, and I think that will help you. Let's change gears just a little bit and start talking about exponents. Exponents are just the shorthand notation of multiplication. For example, if we have something like 2 to the 4th, that would be 2 times 2 times 2 times 2. In other words, you're multiplying 2 by itself 4 times. That is not the same thing as 2 times 4. 2 times 4 is 8, but 2 times 2 times 2 times 2 is 16. So they're not the same thing. How we word a mathematical expression like 5 to the power of 2, well, that's 5 to the second power. We can also call it 5 squared. 5 to the third power is also called 5 cubed. Now our special language stops after cubing, so it's just 5 to the fourth power, 5 to the fifth power, 5 to the sixth power. That's how we shorthand notation of multiplication is just exponents. Order of operation, some people remember it as PEMDAS, P-E-M-D-A-S, but there's a trick involved. Parentheses is for our P, exponents is for our E, M, multiplication, D, division, A, addition, and S is subtraction. But multiplication and division are on the same level, meaning they're equivalent to one another because if we think about it, division is just the opposite of multiplication. Likewise with addition, addition is the opposite of subtraction. They're on the same level. One's not better than the other. So what we do is when we run through and we see multiplication and division in the same problem, we're going to do them from left to right. And that was my left to right. Hopefully it's the same for you, but I think it might be opposite. So just think it's left to right, left to right. I think I'm a mirror in my video, so just keep in mind it's left to right. Likewise with addition and subtraction. So it really is the parentheses, the exponents, and then you have to think about it. Multiplication and division from left to right, addition and subtraction from left to right. Those are the rules that we need to follow. If you don't follow the rules, you won't get the expected outcome. You'll get an outcome, but it won't be the expected one. The odds are it won't be the number we're looking for. Now you should already be familiar with number sequences. Number sequences are just a list of number or objects in a special order. For example, I have blue, green, red, blue, green. What do you think comes next? Well, if I follow the pattern that's going on, red should be next. The great thing about it is humans are really good about figuring out patterns. So even if I didn't tell you what is to be expected, you could probably figure out that the next value is going to be red. Here's another example, but using numbers. 2, 5, 8, 11. Now, what would be, how do I get from 2 to 5? added 3. How do I get from 5 to 8? I added 3. So it seems like there's a pattern going on. How do I get from 8 to 11? I added 3. So my next number in the sequence should be 14. So 2, 5, 8, 11, 14. Another example, 5, 10, 15, 20. What do you think comes next? Well, each one of those was a change by 5. 5 to 10, well, I changed it by 5. 10 to 15, I added 5. 15 to 20, I added 5, so my next value should be an addition of 5. That will be 25. Now there is a very special sequence out there that happens a lot in nature. It's called the Fibonacci sequence. I give you the first two numbers, which would be technically 0 and 1. And then to get to the next number, you would add those two previous numbers together. So what's 0 plus 1? Well, 0 plus 1 is 1. So my sequence is 1 and 1. Now what comes next? I take 1 and I add it to 1. So my next number is 2. But now to get to the next value, I take 1 and I add 2 to it. So 1 plus 2 is 3. My next value, I take the 2 and I take the 3. I add those together and I get 5. For my very last value in this sequence, I took 3, I took 5, 3 plus 5 is 8. So what would be my next number? Well, if I follow along that pattern, then I'll take 5 and I'll take 8, I'll add them together, and I should get 13. The last thing I want to talk about in this particular video is reading tables and bar charts. So given a set of data and looking at it visually, I should be able to answer a question. So this is a table of if I drink some fluids and they have caffeine in it, and I'm given the amount of caffeine, then I can figure out a solution to a problem that I'm given using this data. Brewed coffee has 100 milligrams of caffeine. Instant coffee has 70. Tea has 50. Cocoa has 5 milligrams, and decaf has 4 milligrams. So it's nice that I see it visually in my chart. But now I can answer a question. If you drank 3 cups of brewed coffee, 1 cup of tea, and 2 cups of decaf in one day, we can write an expression that will give us the total amount of caffeine in those 6 drinks. So 3 cups of brewed coffee, that's going to be 3 times the 100 milligrams, because brewed coffee is 100 milligrams. 1 cup of tea, so our 1 cup of tea is 50 milligrams, so we're going to add that to our growing total. That's 1 cup of tea. We have 2 cups of decaf. Well, decaf coffee has 4 milligrams. So 2 times 4 milligrams will give us the amount in our decaf coffee. So overall, we have 3 times 100 milligrams is 300 milligrams. And then we add 50, and then 2 times 4 is 8. So our total will be 358 milligrams. So you can use visual data to get an answer for a written problem. So that's all I want to talk about in this video. Until next lecture, be seeing you.